Hello, everyone, and thank you for attending today's webinar. On behalf of BIS Research, I would like to welcome you all to our Emerging Space Tech webinar on emerging satellite capabilities, enabling sustainability across constellation missions. This is Rahul Papne, Principal Consultant for the Aerospace and Defense Practice at BIS Research, and I will be the moderator for today's event. BIS Research is a leading global market intelligence, research, and advisory company that focuses on emerging technology trends, which are likely to disrupt the dynamics of the market. Our mission is to harness the potential of disruptive technologies to make business thrive and navigate in today's digital age. Today, we are hosting one of the finest scientific minds in the space industry as a guest speaker, Mr. Hirokazu Mori, CSO of Warspace. He entered the University of Edinburgh directly from his second year, read theoretical astrophysics, and graduated from the top. He received a grant from the Royal Society of Edinburgh and has experience in theoretical cosmology research. He has experience as a backpacker and has visited about 80 countries so far. After returning to Japan, he works as a business consultant at a major consulting firm in Japan, consulting on the theme of the new business strategy of the space sector, the global DX strategy. He hopes to go to the moon as an astronaut. Also, we have our host speaker, Mr. Arun Sampath Kumar. Arun is principal analyst within the aerospace and defense practice at BIS Research. With a background in aerospace engineering and an MBA, he has over 8 years of experience covering aerospace, defense, and security verticals. Being passionate about small satellites, he has been monitoring the new space area, delivering market insights to government and commercial stakeholders. Also, we are joined by Nilupal and Amy, who are colleagues of ours at BIS Research and are spearheading the team lead position within BIS Research. So with that thought, let me open this panel for discussion. And I encourage Arun to please take over the forum.
Thanks, Rahul. Uh, Hello, everyone. Thanks for taking time to join us on this webinar. We live in interesting times when the space industry is going through some incredible developments. Credits to the new space markets for contributing to a significant portion of the growth and disruptions in the space industry. Now, we continuously monitor and track the space industry, and when we look into our databases, our database tells us that 155 constellations have been identified so far, and them along with the other operators are going to be responsible for 43,425 satellites in the coming decade. And the timeline we are referring to is 2022 to 2032. And within the same timeline, 7,673 Earth observation satellites are expected to be launched. Now, this is significantly large than what the space industry is used to. At one point in time, the total number of satellites in orbit was a little less than 2,000. But in 2021 alone, a little over 17,000 or 1,700 satellites have been launched. So we live in very interesting times when it comes to the space industry. However, with the growing number of satellites in orbit, the need for enhanced space situational awareness and that capability is on the rise, largely because of the concerns surrounding collision and interference. And constellations are also aspiring to establish in-orbit mesh networks so that they can deliver the next generation of downstream services, both from a Earth observation and also a communication standpoint. With so many satellites being installed in orbit, this situation has opened the doors to many new segments within the space industry. And one interesting segment is the in-orbit servicing segment. Now, in-orbit services as such covers a wide range of activities, covering all the way from inspection, repair, replacement to refueling, life extension, and all the way up to in-orbit assembly and manufacturing. While some of them have already seen successful use cases, the others are under development. But these are things which even a couple of years back, most people would have denied the possibility of. However, we are right in the middle of those use cases being successfully demonstrated. But while these new segments such as in-orbit services market are opening up, What we are also observing is that the Earth observation domain has seen a strong growth, and that the Earth observation domain compared to other domains is approaching the maturity stage where many operators have entered the market. They have installed a LEO satellites, and they have enabled the development and deployment of what is being called as integrated domain awareness solutions in the downstream segment. And with their small satellites in LEO orbits, they have achieved this persistent surveillance through frequent revisits, and they have also enabled the development of a diverse products and services, specifically imagery based analytics and related services. While that is an interesting area to look into, because that comes along with its own set of challenges and new opportunities. At this point, we need to look into the new market, which is just getting started, namely the in-orbit services sector. And for this, I would like to hand it over to my colleague Nilopal Oja. Over to you, Nilopal.
Sure. Thank you so much, Arun, for this introduction. So now, hello everyone, and I'm Nilopal, working as a team lead in space tech domain in BIS Research. So talking about the overall space industry, currently there are close to 5,000 satellites that are active in space. Now, apart from it, we have also launched more than 12,000 objects into the space. Now, most of the upcoming satellite launches are part of either mega constellation or for a particular operation focusing on either communication or the Earth observation in the lower Earth orbit. And the major operator for those mega constellation are either SpaceX, OneWeb, Planet Labs, Iridium. So they have multiple constellations that they are in a final stage of completing and providing the services. Now, having said that, most of the satellite operators are constantly expanding their satellite constellations. Now, this particular expansion, constant expansion of satellite constellation would support the in-orbit servicing, which includes inspection, repair, replacement, assembly, and manufacturing. So there are various companies that are supporting these activities for the in-orbit inspection to repair and assembly. Now talking about the in-orbit servicing market, it is majorly divided into three different sections. So one would be the inspection, repair and replacement. Another would be the refueling and life extension, and the last would be the assembly and manufacturing. Now, talking about the inspection, repair, and replacement of satellites. Now, this activity is usually done to is conducted to keep satellite operational, essentially increasing it beyond its design lifetime or the reliability of its subsystem. So there are companies who are investing and developing those platforms, robotic arms, robotic platforms for inspection of the in-orbit satellites and space stations. Now, talking about the companies, there are companies such as Keysight Technologies who are providing in-orbit payload testing for communication payloads into the various orbit, not just limited to the lower Earth orbit, but beyond that as well. So now coming to the development that we are noticing in the market, as Arun already mentioned, we are living in a very interesting times where there have been already successful demonstration for the inspection, repair and replacement kind of an activity. So now players like Northrop in February 2022 itself, they have planned to launch a new service vehicle by 2024 with the SpaceX rocket. Now, this will be the debut of the company's mission rocket robotic vehicle. Now, this is a spacecraft equipped with a robotic arm that will install propulsion jetpacks on dying satellites. Now, the first customer for this MRVs is Optios, and that company is the Australia's largest satellite operator. Now, talking about the next part about the refueling and life extension. So now basically life extension of a service for a satellite is to extend its operational life by attaching either a propulsion service or either by refueling. So now there are customers who are looking to extend their missions, like the satellites which are there in the geo orbit. They are looking to extend their life in that particular orbit so that they can get additional return on investment. Now, the basic demand for refueling and extension is to avoid more satellite debris as well. Now, as compared to launching a new satellite, refueling is more cost effective. So now, if there is there has to be a very specific cost effectiveness as well, which is there with refueling, rather than launching a new satellite and increasing the satellite debris. So apart from it, even Northrop have previously successfully demonstrated by attaching their platform, satellite service platform, which was the MEV-1, which attached to the Intelsat satellite. So it was done in the year of 2020, April 2020, and it revived a dying satellite into the geo orbit. Now they got that satellite back to the operational stage, and it extended its life. Now, apart from it, Northrop preceding to that as well, in 2021, they have launched MEV-2, which satellites successfully docked on the Intelsat in orbit. And to stay, now this two aircraft will stay together for 5 years to extend the life of this satellite. Now, again, this will increase the efficiency of the satellite and reduce the cost of new launch for the companies. Now, with the success of this mission, this paves the way for the second generation of servicing satellites by offering the robotic platforms. Now, this robotic platform will provide the flexibility and reliance for both commercial and government satellite operators. Now, moving to the next part of the assembly and manufacturing. So, in-space manufacturing includes on-orbit transportation, transformation of raw material into usable spacecraft component. Now, the raw materials can be launched from the ground or harvested in space, depending upon the kind of objective they are looking for. Now, the demand for the assembly and manufacturing is basically based, it will enable construction operation that are independent of the Earth design integration and launch constraints as well. Now, in orbit assembly and manufacturing have the potential to offer the user opportunity to expand the commercialization of the lower Earth orbit. Now, talking about now giving you just a perspective of how we are looking and what is the potential for the in-orbit servicing. Like almost 40% of the object currently orbiting the Earth are simply sitting there to be utilized by the operator. So now for to have them operational in the orbit as well, they will be required to have those servicing, either it is for inspection, repair, or even moving forward to be refueled as well. So now it creates a huge opportunity in the market. Now currently, as Arun previously mentioned, we are looking to have a satellite around 40,000 satellites by 2032. So looking at the opportunity of the replacement of those satellites as well creates a huge opportunity for the overall industry as well as for the in service in orbit servicing. So now taking it to the next part wherein we would be talking about the space tugs and the last mile deliveries of those satellites. I am handing it over to my colleague Amy. Over to you, Amy.
Thank you, Nilofer, for sharing your thoughts on in-space services. Now, the space industry, as we all know, have been once dominated by national space agencies and established aerospace and defense players. However, in the past few years, we have seen a new trend wherein the space industry has opened up to private commercial players. This has led to the emergence of the new space industry as a whole. Now, with the advent of this new space industry, the space industry itself is able to witness immense technological innovations within the space sector. One of these innovations are the in-space services, which has been partly described by Nilopal. Now, the next moving forward from this, we have the in-orbit last mile delivery. Now, in-orbit last mile delivery has the capability to enable the other in-space services as well as change the dynamics of the overall space transportation. Now, in the past few years, we have seen that there has been significant increase in the launch of small satellite constellations being launched by SpaceX and OneWeb, and we would be seeing that in the upcoming years as well, wherein Amazon will be launching their Project Kuiper small satellites. As Arun has mentioned, we here at BIS have are forecasting that the number of satellites that will be launched will be more than 43,000 by the end of 2032, out of which small satellites form a major part of it. Now, this increase will lead to a demand for dedicated launch services, which can be achieved through space tugs or orbital transfer vehicles, as we call it. Now, space tugs have the capability to deliver customer satellites, which can be placed at precise orbital slots, whether it is at LEO Earth orbit, medium Earth orbit, or geostationary Earth orbit. Now, these space tugs, enable the customers to decrease their overall cost as well, because the customers can reduce their satellites, onboard propulsion, because space tugs have their on-orbit propulsion capabilities. With that, they provide the customers with the options for various orbits, thus addressing the increasing need, the market need for in-orbit space logistics. Now, due to these space tugs also, the need to rely on heavy lift launch vehicles for transporting payloads for deep space missions or explorations also decreases, because they can give that the provision of dedicated launch services is there. Now, apart from that, the space tug will also be utilizing other robotic technologies such as robotic arms. For instance, the made in space robotic arm will be mounted on a momentous Vigoride transfer vehicle. This is the orbital transfer vehicle by Momentous, which is focused on transferring payloads to low Earth orbit. And with the robotic arm, a Vigoride could grab onto a satellite in space and move it to the desired orbit. Having said that, why does the space industry need in space transportation or in orbit last mile delivery service? One of the major objectives of this service is to transfer the transfer of payloads to a precise destination in orbit, where the satellites is expected to operate, and this gives the possibilities for the customers to achieve the precise inclination and the precise altitude that their satellites need to be placed for their operation. Now, during 2020 and 2021, it was observed that key players like Momentous have signed and gotten several launch services agreement with several others commercial space entities for its Vigoride orbital transfer vehicle. Apart from that, we have another company known as Space Machines Company, which is an emerging new space startup. And last year, has announced that they have onboarded four Australian startups, Spiral Blue, Esper Satellite Imagery, Space, and Dandelions as customers to launch its first orbital transfer vehicle called Optimus. Now, apart from that, there are several various factors that are catering to the demand of in-space last mile delivery. One of them is the high reliance on secondary ride-share services. Now, waiting for the right slot in your launch vehicle is one thing, but it will not guarantee the specific orbital slot. This is where the space tugs come into the picture, wherein they will provide you that custom service of payload delivery. Now, another factor contributing to this growth would be the optimization of satellite operations, wherein the customer satellites will be placed at the precise orbital slot. Another factor attributing to this growth is the focused efforts on emerging in-space services. Several companies are developing and demonstrating those in-space service capabilities, whether it be in-space refueling or life extension services. Now, there are several key players operating in the market currently, and we have Momentous Space, D-Orbit Space Machines, Astrobotic Technology, Maxar Technologies, Exotrail, Transastonica, and so on. So these companies have showcased and will be showcasing their in-orbit last-mile delivery service capabilities. As you can see, we have noted down some of these, developments and activities that these companies have been working upon. For instance, during May this year itself, Momentous has launched its orbital transfer vehicle Vigoride's first demonstration flight to the low Earth orbit on board a SpaceX Transporter 5 mission. The company has also announced that it has placed its first customer satellite in the precise orbit and plans to conduct more deployments for their customer payloads. Now, apart from that, we also have another company known as Exolaunch. It is a German-based company, and in 2023, it aims to flight test their orbital transfer vehicle called as Reliant. Through this demonstration, they will be able to look into the different configurations capable of making. Additional adjustments, including the various inclinations of of the satellites. Now, apart from this, in order to achieve successful satellite operations, ground station networks play a very crucial role. And to discuss on this aspect, I will call over Arun. Over to you, Arun.
Thanks, Amy. Now that we have seen the recent developments with respect to the emerging segment within the space industry, we need to get back to our focus on the Earth observation domain, which, compared to the communication domain, the Earth observation domain has, multiple players. The constellation size per participant or operator would be significantly low, but there are many players, and we did see that, decades forecast is well over 7,000 Earth observation satellites. Now, most of the ground stations are anyway concentrated on the northern hemisphere. Not so many locations are present in the southern hemisphere. Previously, the Earth observation missions did not involve so many satellites, and the revisit ranged from anywhere between 4 hours to 3 days. But that has come down significantly, and some of the smallest revisit times that we are noticing are of the order of 34 minutes and below, and we do expect it to go below the 15-minute timeline. However, what that causes is the need to be able to speak with the satellite in an on-demand basis, because downstream the market is getting fragmented. The geospatial services segment is having over 600 participants, and so everyone is scrambling for as much data as possible to provide actionable insights across the industries, and that means they need to be getting the most recent data as quickly as possible. So the time between the capture of the imagery to the delivery of the actionable insight becomes critical in terms of differentiating one service from the other, and that subsequently establishes the competitive advantage amongst the participants. Now, with the given ground station infrastructure, operators have limited options in terms of communicating with their satellites in an on-demand basis. While at one end, digital aggregator platforms are being developed by participants such as RBC Signals, Infostellar, and so on, and they are basically integrating excess capacity into digital platforms where operators could schedule their exchanges with their satellites. At the other end, the ground station segment itself is evolving in terms of setting up new terminals. However, that is an evolutionary process. It is going to take time. In the meantime, multiple participants have developed optical communication technologies to provide an additional capability of both satellite to ground communications and also inter-satellite communications. There are multiple participants who are developing similar technologies, and this optical communication technology, the way we see it, is not necessarily going to replace the existing RF infrastructure, but it is going to provide an additional mode of communication for the operator. So they could be communicating with their satellite even when their satellite is not within the view of a conventional RF based terminal that would be used for their mission operations. Now, this addition of this optical communication layer will have multiple impacts. At one end, it's going to add more hardware on the satellite platforms. It is going to create the demand for a large volume of downstream terminals, and at the same time, it is going to be connecting the satellites in orbit, enabling mesh networks, and that is going to drive a whole lot of activity at the upstream segment, where the satellite networks are going to replicate what the terrestrial cloud infrastructure is doing in terms of providing large volume data storage and distribution services. Now, those inter-satellite links and the satellite to ground links, are going to rely on these optical payloads. And we have been looking at these participants, and one interesting participant that we have come across is Warp Space Incorporated, and they are developing this optical capability to enable the space industry. And it is about time we start hearing from them about their journey with the development of optical capabilities and how they intend to revolutionize the space industry. At this point, we would like to hand it over to Mr. Hirokazu Mori. Over to you, Hirokazu.
Hi, thank you for introduction. I'm Hirokazu Mori. I'm Chief Strategy Officer of Warp Space Inc. and also CEO of Warp Space USA. And here, so I would like to introduce what we do, and probably presentation takes 15 minutes or so. So after my presentation, I would like to answer most of your questions. So next page, please. Would you mind sending to next page? Can you hear me all right?
This one?
Yeah, the bottleneck in the industry, this one. So why we do this? So basically, so Arun, explained most of the issues in Earth observation industry. So most of the small satellites these days are launched into low Earth orbit due to the decrease in the launch cost, mostly owing to SpaceX. And the problem of that, since the altitude is very low, the access time for the satellite to access most of the individual ground stations is less than 10 minutes per orbit. And most of the time, they have to do the frequency coordination. Like launching satellite is not just technology and regulation bit. They have to do careful adjustment, talking with other government, and they have to discuss with ITU in order to register their satellites. That takes a lot, like 2 years, because most of the major communication constellation, they took most of the frequency already. And estimated opportunity loss is around 200 billion US dollars, since 90% of Earth observation data is actually not downlinked. Even though they can take a picture, they cannot downlink, so it's just wasted. And that's where we come in. Please go to the next page. I don't see the next page. Is it just me?
The next page has our solution with optical communication. That slide?
Yes, this one. Okay, yeah. Now I see this. Sorry, there's a lag in my communication. So that's where we come in. We are going to launch 3 relay satellites into medium Earth orbit, about 2,000 kilometers up there, in order to relay the Earth observation data from Rio to Mio, then back to ground. And why we use optical terminal in order to basically transfer the data. Why? Because it's much faster than traditional RF. The best RF communication is probably done by Ka band. That's probably at maximum several gigabytes per second. But when it comes to optical links, it can go to say 100 gig or could be 1 terabyte per second. And we are trying to actually start from 2.5 gigabyte per second. And that's already faster than most of the best performance array has. And also, since our relay satellite will be coordinated in terms of frequency, our clients in low Earth orbit, they do not have to do frequency coordination. That way, as long as they have the specific terminal, they can just launch it without doing all the coordination and application. And since we are relaying the data, our clients in low Earth orbit should be able to downlink the data in near real time, say 10-15 minutes for 24/7. That changed the industry by lots. Please go to the next page. So our vision is basically, we just made a new vision, making a connected space. As Arun introduced and as I explained, Earth observation industry in space has been very, very old in a way. Like there is not many nodes, and the only time for satellite to actually downlink the data is basically when they are orbiting around the Arctic. Right? It's very, very like primitive, and we are trying to make something we have on ground. Basically, there are a lot of TCP/IPs and the ground networks, data centers, and edge computing in order to actually realize those terrestrial internet infrastructure. First, we need the way to actually communicate to each nodes. That's where we are going to actually make. Please go into the next page. So the market size we are looking into is around 1 to 2 billion US dollars in terms of sum. I take these days the whole Earth observation industry in the world is called 30 billion US dollars so far, which also includes application of Earth observation data, and around say several percent of these whole market size is actually going into the ground segments, right? Such as ground stations, etc. That's where we are going to take as well. And this industry as a whole is growing at the CAGR of 10%. And we saw a lot of like different reports saying that CAGR for optical intersatellite link market is like 20-30% in terms of CAGR. So anyway, this field is a lot of people are actually looking into, and so many big firms like Nokia, Lockheed Martin, and Sony, Airbus, they recently just entered. That probably can say that it's evidence that this field is really promising. Next 3 to 5 years, it's gonna definitely grow. Please go to the next page. Yes. So how can we contribute to the economy on the Earth? There are several ways. So our clients could be optical optical constellation or SAR, synthetic aperture radar, could be RF such as Hawkeye, and these days hyperspectral constellations are coming up such as Pixel from India, and all of them have different application, but all combined like they could do many things such as automating or primary sectors such as agriculture, forestry, and fishery. Satellite data has been used to actually monitor fields for years, but the issue was, say, temporal resolution and spatial resolutions. Today, like company like Planet, they offer daily data with a spatial resolution of 3 meters. That is good, but we hear the voice from like farmers that they would like to actually check the difference within a day. That cannot be done. Planet has already 200 satellites, but still they cannot do it because of ground stations only around the Arctic. If they use our service, they should be able to take the data like hourly. That's gonna change the solution as well. They're gonna be new application or apps farmers can use, and also logistics. Today, everybody has a problem with logistics, but in order to monitor the ships or cars or trucks, still the temporal frequency is not enough. If our clients could use our service to relay the data, they should be able to get the data more frequently, say hourly, perhaps like every 10 minutes. And most importantly, building a resilient society. So these days, for example, in Japan, we have lots of flood, typhoons, and sometimes earthquake. In order to act against these natural disasters, getting the data in near real time is really important. And today, I think the fastest we can get the data is probably around like 2 to 3 hours for natural satellites, but that's not fast enough. In order to actually plan and the counter disaster management, and the government has to make the committee, but they really want the data, say, in 10 minutes, or they want to actually check the field or the area like every 10-15 minutes in order to make the plan. We don't have any means to actually monitor those areas. So that's where we come in. If the satellite and Earth observation players, either public or private, if they use our service, they should be able to get the data every 15 minutes and in near real time. Please go to next page. So this is basically summarizing what we said, what I said. The value of our service is the amount of data they can downlink, that's going to increase, and also responsiveness means low latency. They should be able to get data quickly in 10-15 minutes, and more data means these days everybody use AI or machine learning to make application or solution. Their prediction accuracy gonna go up, and also the coverage and the frequency. Today, the reason satellite players cannot take the data often is because coverage and the frequency is not enough in order to actually get the data. We're gonna help that as well. Could you go to next page as well? So the business model we are going to actually employ is like this. And our direct clients are EO satellite operators such as Planet, Synspective, Capella, Pixel, ISI, Aspire, Satellogic, those people, not just these. And we are going to charge those companies based on the data they actually transfer. So it's going to be very fair. It's we are going to employ the way how major cloud services are using. And also, we are also discussing with several different governments and the government agencies as well, not just space development agency, also like NOAA, NGA, those agencies related to not just military but meteorology and also land monitoring as well. And usually, mostly we talk with US and Japan, but we are going to talk with several other governments, including India as well in near future. Please go to next page. So also, say next 5 to 10 years, we focus on this, most, how can I say, to the ground, most important field which contribute to Earth economy, which is LEO Earth observation industry. But our technology is actually useful for long distance communication as well, right? And probably most of the audience know how RF and optical works. Optical means laser communication. It's point to point. If it's a RF, the signal is actually dispersed. The signal strength decreases proportional to in proportional to the square of distance. But laser doesn't really, lose the power, right? Based on the distance. What we are trying to do is we are going to provide our service to the moon and perhaps to the Mars as well. But in fact, please go to the next page. We have started working on it with JAXA that we could probably send some of the important data to the moon and also around the moon in order to actually support any industry on the moon. So on the moon, there's gonna be many different players gonna play on the moon. There are a lot of construction companies, telecommunication companies, and also how can I say, resource mining companies, and also they're going to be maybe hotel, etc. But definitely they need communication, right, in order to actually support any device in order to actually control the robots on the moon. They really need a strong communication infrastructure in order to communicate real time. And we have done the feasibility study how optical communication relay service could be useful for, say, Artemis plan. And we will work on actually making satellites for JAXA. Then in the end, that's going to contribute to Artemis plan. But that's a long-term plan, maybe in 5 years or so, we will start launching those satellites as well. Please go to the next page. And also, as Arun explained, we gonna start optical ground station service as well in 6 months or so. And the problem of optical ground station is basically clouds, right? And it's basically the technologies is almost identical to telescope, which is used for astronomy. When there's a cloud, we cannot really communicate. In order to avoid those issues, basically we have to have several optical ground stations in different locations. And we are gonna have one of the ground stations in the southern Japan area to begin with. We're gonna start our demonstration early next year with other clients as well. And we're gonna have some more outside Japan, like Australia, like Africa, those area. Please go to the next page. So let me introduce the core members. So our company actually started in 2016 by our chairman, Professor Kameda, and also our CTO, Akihiro Nagata. And when they started the company, and we used to do totally different things like building just antennas or making a GPS device. But when our CEO Satoru Tsunemachi joined Workspace in 2019, we really actually started this optical intersatellite business. And last year, after we raised Series A, our CFO Akiko Kitahara and me, Hirokazu Mori, joined the company to actually accelerate the business, not just in Japan but also in States as well. And it's worth noting that some of our advisors are really famous people, I would say. So two of our advisors used to be a director of Japanese Space Agency, especially the counselor Takashi Hamasaki. He has been working on some of the major national Earth observation satellites, such as ALOS, GOSAT, and you may have heard of it. Those are like representative Japanese national Earth observation satellite. He was a project manager of these satellites, so he's been advising on us what kind of a relay service we should have in order to be useful for those Earth observation companies. Please go to next page. And as I said, we have just raised Series A 6 months ago, and we are raising Series B now. Up till now, we have raised around 10 million US dollars, and we are going to raise several tens of millions in few months in order to fund the first several satellites and also launch as well. And it's also worth noting that, Keisuke Honda, the very famous professional football player, he's now also angel investor. He has invested in us. And also Yuka Tanimoto, she's very famous in a Japanese startup ecosystem. And she's one of our external board and also investor as well. Please go to next page. So as I introduced, we now have a US branch in Washington, D.C. in order to actually promote our business in States. Especially, you may have, I don't know, in this field, like optical intersatellite links market, space development agencies in United States is playing a very, very important role. They have invested like several billions, like a risk money into this field. This is one of the reasons these days lots of people started to talk about optical communication, even though technology was present for more than 10 years. And we've been talking with SDA actively, including like other agencies as well. And hopefully we will actually start providing our service to US governmental agencies in few years as well. Please go to next page. Yeah. So that's all for the introduction on Workspace. Thank you for listening, and I'm happy to answer to any questions.
Sure. Thanks, Hirokazu. Before we move on to the Q&A session, just a slide for summing up all the key insights that we have seen so far. Thousands of satellites getting launched, and this opening up new market segments within the space industry, namely the in-orbit services segment, and new capabilities being developed as a consequence of these developments, and some of the technologies like the space tugs looking to even enable future deep space missions, and with the ground station infrastructure evolving and with new optical communication capabilities coming into play, the industry is moving forward in many directions. And the need for space situational awareness at this point seems to be peaking, and that market is also expected to grow moving forward. There are many commercial participants who are actively working in that area. And overall, the in-orbit processing is going to go up, and the satellites are going to go through a fair bit of change with respect to how much hardware they carry and what they do with the hardware while in orbit. So the cloud-based services using terrestrial infrastructure is looking to expand its footprint into space as well. So interesting times overall. Thanks to Hirokazu for taking time to take us through their developments and travel so far. Before we move on to the Q&A session, I would like to hand it over to Rahul for some concluding remarks. Over to you, Rahul.
Thank you very much. Thank you, Mr. Hirokazu, for providing so great insight. And thank you, Amy, Arun, and Nilopal for the concrete area items that you have discussed with the team. Of course, Arun started with the overall space trends, like that, what's happening in the new space markets and all. And Nilopal and Amy pitching into, giving us more details on the in-space and manufacturing and servicing area. And of course, Hirokazu being very detailed on the what plans the WatchSpace has for optical communication as a market. So we also do understand, I mean, especially the areas like optical communication, where we have of late seen companies like Sony Corporation has just now ventured into creating their own optical communication business for satellites. So that's a very innovative and as well as at the same time very I would say business oriented strategy, where a lot of the electronic companies and anything which is into the supply chain would want to enter within this sector. And I think, as Arun has mentioned, this is a very innovative and very great times for the space industries. And accordingly, this, as you can see on our screen, a lot of our research studies are focused on to help clients understand these markets. And of course, these studies are off-the-shelf studies, syndicated studies, which provides you fundamental understanding of the what's going to happen in next 5 to 10 years within these specific areas. In case anyone has got interest, they can of course reach out to us, our marketing team, and we also do provide a customized market understanding about these areas. So any specific query or any specific area which any client want to understand, please feel free to reach out to us. Having said that, I would just want marketing team to showcase some of the links to whoever is watching this webinar at this point of time, and provides the link of some of these studies over the chat. Thank you, Em. Thank you, Emmet, for sharing these links of these topics which we have published. So now I think it's a good time to have the Q&A session. Let's have the Q&A session. We will take one by one each question. Okay, so one question for you, Hirokazu, is do you see or the company WatchSpace see the production plans, any production plans for these optical communication devices that you foresee? And if yes, which kind of segment would be more interest to you or the organization?
All right. So, okay, that's interesting.
So that's a very confidential question, but still I would say, I mean, what sort of details you can provide to our listeners?
All right. So optical terminal we developed, right? We haven't really announced it, to be honest. Yeah. But we will be able to actually provide it in the next year, right? Next first half of next year. Yeah. But it's gonna be very small. Yeah. But it's a good question. There are so many different companies who manufacture the optical terminal these days. I would like to just say that our focus is basically providing a service. We are not really focusing on manufacturing one, so we may actually change our strategy in a way.
Right.
To just focus on the providing service.
Right. And do you see any sort of challenges when you are sharing these kind of devices for the markets? What sort of challenges do you see at this point of time?
yeah, so probably when it comes to mounting those devices, I think most common issues or challenges are where to, the interface where we can put the optical terminal. Obviously, since it's a communication device, we have to put in somewhere outside or the face, right? And there's also the visible range for each terminal. And where depending on the satellite, there's a limitation which face we could put it on. Sometimes we have to put two instead of one, or even if we put two, there's some that how can I say dead side where we cannot see. So we have to consider the orbit and the time schedule in order to communicate. Those are probably the challenges. But apart from that, yeah, optical terminal has advantages against RF.
Right. Yeah, so just one last question out of curiosity. I mean, Sony has just entered into this business of optical communications. So my question would be like with so many, big players coming into picture. So how do you see the competition going to, come up with a company like Warspace? And also, as Arun has also mentioned, I mean, the RF is going to stay here, right? It's not going to go or, immediately go. So how do you see both these areas and competition going up in the future?
Yeah. So I guess like there is definitely a need to downlink more data. So definitely the demand for RF just stays as it is, but just there gonna be more and more demands on top of it, which cannot be downlinked. That's where like we could come in, like optical communication people, right? It doesn't have to be relay. So I think next year lots of people start demonstration between ground to LEO, right? That's gonna be the start, I think. Then in 2-3 years, I think we are one of the first to do the in-space demonstration as a commercial company. And when those like inter-satellite optical communication starts, that's where really the market kicks in. And low latency, secure, and more powerful communication will come in. But and in order to actually answer to the first question, obviously like Sony, Airbus, many big firms just come in, but most of them focus on manufacturing, not really the service. So for us, it's not much threat. It's actually more preferable for us because we can get basically the number of suppliers just increased. In the end, if there is a good optical terminal out there, we can just use them, like in order to actually improve our service. So, and also we have several IPs for architecture. That's gonna help when this like optical communication market kicks up, and our IP gonna be very useful in a way, so that that's where we could also make money as well.
Right. Thank you, Hirokazu. Thank you for the answers. Appreciate that. So we have another question coming on with us. So it's basically meant for I think Amy and Arun can answer it, which is how do you see the in-orbit servicing market? I mean, is it, of course, it's a very innovative area. A lot of companies want to enter into it and are actually entering into it. But which segment do you see is going to get commercialized in terms of monetary value and as a business also in next few years?
Sure, Rahul. Amy, you want to go first?
Yep. Looking at which in-space service will be commercialized first. We have also spoken with different industry experts during our analysis and everything. And as per our analysis also, we may be able to see life extension services coming into the picture first, wherein there is a need for the life extension for geo satellites, and provided there is the provided that the industry is willing to pay for that services. And we have already seen previously, as well as Nilopal has mentioned before, we have seen that demonstrations have been conducted by players like Northrop Grumman for their mission extension vehicles 1 and 2, for the customer satellites, which is Intelsat satellites. We have seen that demonstrations going on, and it was successfully conducted. So in my opinion, it would be life extension services. Arun, you want to add anything to that?
Sure, Amy, thanks. I agree with Amy. It's going to start with life extension, and I presume it has already started because, from a financial standpoint, the cost of such a life extension mission is significantly smaller compared to the overall cost of a geo satellite mission. So it makes better financial sense if such a small investment could extend the life even by 3 to 5 years. That would make a huge difference in terms of the overall return on investment. But coming down from geo, most of the satellites are getting launched in LEO. The question of sustainability and safety is just getting stronger and stronger. So the ability to deorbit satellites before placing the replacements is going to grow, and it is already growing high. Some of the satellites might be expected to burn out on their own self-cleansing missions, but we are talking very few. And that, there is no confirmation that they are going to deorbit automatically after a certain point in time. It all depends on how their orbits decay and at what point they re-enter the atmosphere. A lot of them are not going to go through that phase. They are going to have to be moved to graveyard orbits. Some of the satellites are going with onboard deorbiting propulsion capability. So at the end of the mission, they have onboard capabilities to do so. Again, it comes with a risk because that is one capability that remains dormant for significant portion of the mission. Although it is 3 to 5 years, for 3 years something remains inactive, and then it is expected to be fully active and fully efficient to move the satellite. So the chances are, the risks are there. However, only some satellites go to orbit with such capabilities. A good chunk of them are going to rely on specialized deorbiting services. Again, it is going to be small satellites. The same activity as in the life extension, except instead of orbit raising or any other station keeping activity, the deorbiting satellite would basically rendezvous with the target satellite and move it to a graveyard orbit. So, after the life extension, it is going to be deorbiting services. However, the space situational awareness capabilities and other enabling capabilities, and most importantly, the regulations which could potentially impose the need for having such activities done. Those too many things have to fall in place. But given the current circumstances, we expect them to fall in place eventually. And the next best thing after life extension is going to be deorbiting services. That would be our view.
Right. Thank you, Amy. Thank you, Arun, for the answers. So one last question I think we can take as I think time can permit us. Yukazu, I think you can answer it. Do you think there will be data format issues or data format conversions issues when shifting from conventional satellite communication to optical satellite communications?
Yeah, good question. In terms of format, not much problem. Basically, so for our, for example, relay satellite players, we basically do not touch the data, right? And there is an issue of, since it's a relay satellite, if we just hold the transfer of the data, then we restart it. We have to think how we could connect it, and also the bit loss rate is a kind of a problem. But there are several technology for optical communication to reduce bit loss, and also say overlapping a multiple wavefront in order to reinforce each other's like a signal as a one laser. So there are several technologies. So we don't really change the data format. We could just, like our clients can just transfer the data as it is. And on the ground, they probably have to do, say, decryptalization, or maybe they have to do something. That's probably your problem, like a data format problem, will be probably the issue for edge computing people. I know that they have some problem, that because they cannot really do the analysis of, without doing, without touching the data. Those people actually have a problem, but for us, not really.
Right. Thank you, Yukazu. I think we are left with some time now, and in case we are not able to take any questions today, we will of course revert them via email, or in case anybody have any specific questions, they can even post and ask us via an email. We would be happy to have those answers coming in later after this webinar also. Also, in case anybody is interested in any other documents which is related to this specific theme or any specific query around optical communications or overall space situational awareness thing, again, please do feel free to ask these questions to us, and we hope to have more such webinars in the future also, and we'll see you later. Thank you very much. Thank you very much, guys. Appreciate your time, and it's a great learning experience for all of us. And we'll see you soon. Have a happy weekend.
Thank you.
Thanks
Thanks for
everyone.
listening.
Thank you.